Hi folks, today I bring you another integrated circuit in DIP40 format with the reference S1998, a complete clock from the manufacturer AMI, American Microsystem Inc. Despite being a dinosaur, it deserves some attention. This type of the integrated circuit, which constitutes a complete clock if we use the 50 Hz from the sector, allows use the 12 or 24 hours format with the sleep and alarm options. It was not easy to find any reference on the web besides the content of the book of the manufacturer, but at least it is a reference in the equivalence books from the 80s, such as the RCA and the ECG, which is already a great help. There are a few dozen tests and measurements confirmations to ensure that we are proceeding correctly when trying to bring the IC back to life. We found incorrect information even from the manufacturer itself, and finally we got a functional clock based on the S1998. As already mentioned, anyone who has handled the LM8361 will not notice any major difference. It is a clock that can adjusted by two buttons, one fast and one slow, which also serve to eliminate the blinking after the power failure. Once again, I would like to emphasize that this is a PMOS and as was common in the nomenclature of the time, VSS is the positive and the VDD is the negative. Pay close attention to this warning, otherwise it may result in the destruction of the IC. Look careful at the circuit diagram and pay attention to the polarity of the capacitor used as a filter. This will help you in case of doubts. I recommend watching other videos on the channel where this topic has already been covered. Normal, this kind of the ICs use a display with the 4 digits. Sometimes the first digit, the digit of the 10th hours, is half digit because only need to represent the digit 0, 1 and 2. Okay, this is the configuration of 12 hours, and when I disconnect the power, I need to discharge the capacitor in circuit, and when the power up return, you see the blinking of indicator of the power failure. They use the AM segments and the PM segments in the format of the 12 hours to indicate the power failure. When I press the first setup, you see the PM segment now is fixed. Okay? I repeat. Now the indicator is the AM segment of AM. I repeat the test. The fail of the power, the return of the power, the PM segment blinking. When I press, for example, the set of the minutes, you see the segment is fixed now. Now I proceed with a round trip of the hours, complete hours, 7, 8, 9, 10, 11, 12, the indicator of the AM or PM change. This is the setting to the 12 hours. Of course, you have the sleep time, wake up, seconds, and alarm. After some time to try understand the connections of the digit related with the tens of the hours, I'm able to put the system with the 24 hours. The process of the fail of the power is the same. I disconnect the power, and now we have different segments blinking to indicate the power failed. But this is normal because the segments have changed or have swapped in this digit. If I press the first button to set, the system stops of the blinking and I am able to adjust the hours, the minutes, and all the other times present like alarm, sleep, and so on. Okay, we go do it round trip to all the hours present in the display. 11, 12, 13. Okay, instead of skip to the 1 hour of the afternoon, we skip to the 13. 20, you can see the segments is in the correct format. 22, 3. Now I use the minutes. 3, 4, 5, 6, 7, 8, 9. Okay, 0 hours. And we have the possible to keep the blinking of the seconds. The output of the 1 hertz is not used to set the hours digit in the 24 format hours. If you compare with LM 8361, the pin of 1 hertz is used to create the first digit of the hours, okay? I used the generator of the 60 hertz with a crystal and C to adjust and 2 C's to proceed with the filter. The next time we will work with the LM8361 and we will go use the 50 hertz from the sector, okay? To power the 4 7 segments display, I used a 2N2222 transistor with the base current adjusted by a variable resistor. I also applied a set of the limiting resistors to avoid excess voltage on the displays. This method with the transistor helps to avoid brightness variations when there are more or less active segments. The power supply used during all the tests has 12.5 volts DC. Of course, a resistor can be used for each display. That is a common cathode, which means that the resistor must be between the cathode and the negative terminal. The other options would be to connect the cathode direct to the negative terminal and a resistor for each segment.